Okay, this video is meant for geometry. We have a quiz coming up on Monday or Tuesday covering the first 5 sections in Chapter 10. And let's take a look at some of these questions here. Alright, first one. We're going to find the area of this polygon. So we're going to graph this. So 3, 9. 3, 9. 1, 2, 3, 4, 5, 8. This plays tricks with me visually. So there's A. B is at 8, 9. 1, 2, 3, 4, 8, 9. There's B. So we just start by graphing. C is at 2, negative 3. And D is at negative 3. Negative 3. And here we go. So let me see if I can connect this figure sort of right. So we have this figure right here. Right? It looks to be a parallelogram, okay? So we have a parallelogram here. So this is a parallelogram. So the area is, of course, base times height. So I need to know what the base and height are. Well, in this picture, this parallelogram is drawn in such a way that let's call DC the base. So this is my base. And what I'm going to do is I'm going to draw a dotted height. So remember, don't be confused if the height's on the outside, right? And there's the height. Okay, so do not be confused. And remember, every parallelogram has 2 bases and 2 heights. But let's use this base because it's horizontal, and this height because it can be vertical. And we count, right? So DC is 1, 2, 3, 4, 5. This is 5 units long, and your height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our area formula is simply 5 times 12. And that would be an area of 60. And don't forget your units. So this would be units squared. And there's the area. Okay, next one here. Find the area of the figure. And this is an irregular figure. Okay, so what I need to do is I need to break this figure into 2 shapes that I know how to find the areas of. And I'm going to draw this dotted vertical line down here, which creates a rectangle in my area 1 and a triangle in my area 2. So I'm going to find these 2 areas and then add them together. Okay? So again, area 1 is a rectangle that is base times height. So what is the base? The base is 60 and the height is 120. And this area comes out to be 7,200, sorry. 7,200. And that would be meters squared. So then area 2 is a triangle, 1/2 base times height. Now, this 200 goes all the way across. So, if that's 200, I only want this part right here. Right? That's the base of the triangle. This is the right angle. Remember, the legs of a right triangle are your base and height. So what is this right here? Well, if this is 60 because it's a rectangle and the whole thing is 200, that means that this is 140. There's your base. And we'll do the same thing here with the height. This 120 goes all the way across. Well, this part is 40, so then the height of my triangle right here is going to be 80. Because 40 and 80 make 120. So the area of this triangle is 1/2 the base, which is 140, times the height, which is this 80. And that's going to be half of 140 is 70, 70, and 80 is 5,600. And that's meters squared. And now I'll add this together to get the total. So area total is 7,200 plus 5,600. So the area total is 12,800. And that would be meters squared. There's your total area. So find 2 regular shapes, add them together. Next here, find the area of the trapezoid to the nearest 10th. Okay? So down below here, area of a trapezoid, 1/2 the height times the sum of the bases. And remember, think of it as the average of the bases, b1 plus b2 divided by 2 times the height. Right? So in this picture, this is a vertical trapezoid. So your bases are here and here, and your height, which we don't have, could be here, or let's draw it in here. There's your height. So in this formula, I do have the bases, but I don't have the height. So I need to find the height. And to get the height, I'm going to use this triangle. You see this right triangle here? 45, 45, 90. Label the three sides. S, S, S radical 2. The height is going to be S. We are given S radical 2. S radical 2 is 1.7. So to find the height, divide by radical 2. And I'm going to leave this out to a couple decimals. Okay? So 1.7 divided by the square root of 2. That comes out to be 1.202. So you just leave it out to a couple decimals. And that is what H is. H is 1.202. So now, in my formula, area equals 1/2 my height, 1.202, times base 1, 0.9, plus base 2, 2.1. And when I do this in the calculator, 0.5 times 1.202 times, that would be 3. 1.8. 1.8, and that would be meters squared. So be ready for these special right triangles, okay? And even Pythagorean theorem. Alright. Next. Okay, we have an area of a rhombus, and we're going to just do decimal. No worries about the simplified radical. So, area of a rhombus, just like a kite, 1/2, diagonal 1, diagonal 2. Now, in this rhombus, two things happen. Number one, the diagonals are perpendicular, so all four of those angles are right angles. Number two, the diagonals bisect each other. So if that's 8, so is this, and then these two sides will be the same. Sorry, those two parts of that diagonal. So this one and this one. So we have one of the diagonals, right? This diagonal that goes straight across here, and I'll try my best. I'm going to do it. The one that goes straight across, right? That diagonal, call it diagonal 1, that's 18 inches, right? 16. 8 and 8 is 16. So now we're in charge of finding what is this diagonal. Call this diagonal 2. Okay. Well, to do that, we're going to focus on a right triangle. And what I'm going to do is I'm going to actually bring that down here in the space below. So that's a right angle. This is 8 inches, and this is 30. And this is actually a 30, 60, 90 triangle. The labels for a 30, 60, 90 are S across from the 30-degree angle, 2S, the hypotenuse, that's bad, 2S, and the third side is S radical 3. So I would like to find this side right here, call this X. Well, my X is where the S is, right here. So I need to find this short side. So I need to know what S is. Well, they give you what S radical 3 is. S radical 3 is 8. To find S, divide by the square root of 3. And 8 divided by the square root of 3 is 4.62. And that's what S is, 4.62. If you take it out to 3 decimals, that's great, okay? But that's fine, 4.62. So that is what S is. That is what your X is. X is 4.62. X is half of this diagonal, so to find diagonal 2, we're going to multiply this by 2. 2 times 4.62. And that'll give me the entire length of that diagonal, that vertical one, 9.24. So the diagonal going vertical is 9.24. And now I have my area. 1/2. D1 is 16 times D2, 9.24. And when I do this in the calculator, 0.5 times 16 times 9.24. And I get 73.9 as my area. And that would be in inches squared. Okay. So again, be ready for these special right triangles. Remember, you can always use trig if you don't like the special right triangles. Okay. All right, next one. Here we go. Find the area of the regular polygon round to the nearest tenth. This is a hexagon, and a hexagon means you have 6 sides. The area formula for a regular polygon, area equals 1/2 AP. Remember that P is N times S, right? So in this picture here, This 18 feet could also go right down here. I'm going to put it right here. So then if I were to draw my picture, here's my center, there's my 2 radii, there's my apothem. And that's my side. Okay? So I'm actually going to draw this picture down below here. So I'm going to draw it right here. Right? So there's my radius. Here's my apothem. Here's my side length. And the side length is 18 feet. And the question is, what is the area? Well, what do I know? I do not know the apothem. I know the number of sides is 6. And I know the side length is 18. So I'm in charge of finding the apothem. So to do that, remember, we start with the central angle. So I use a different color here, orange. So to find that central angle, take 360 and divide it by the number of sides. That would be 6 here. So each of those top angles is 60. And now I'm going to take this triangle, say on the right, and I'm going to put it right here. So this is the apothem. This is half of the side length, so that's 9 feet. And this angle is half of that central angle, so that's 30. And again, this is another 30, 60, 90 triangle. Now, I'm not going to use S because of the side length, but I can use X. So across from the 30-degree angle is X. Across from the hypotenuse is 2X. And the third side is X radical 3. I want to find A, which is X radical 3. Now, to do that, I need to know what X is. Well, look at that. X is 9. I'll do it right down here. So if X is 9, then A is 9 radical 3. And there we go. So now I have my value of A, and I put it right up here. And I use my calculator. So I'll do 0.5 times 9 radical 3. Make sure your calculator, you close the parenthesis around the 3, times 6 times 18. And I get 841.8. So let's just go 842. No, 841.8. Ask us to round to the nearest tenth. Okay, and that would be in feet squared. So remember, this is a special right triangle problem. However, if you want to use trig, that's fine too. Okay. All right, a couple more left. Here we go. Remodeling. So this is a section 4 problem. The scale factor of the dimensions of 2 similar wood floors is 4:3. It costs $2.16 to refinish the smaller wood floor. At that rate, how much would it cost to refinish the larger wood floor? Okay, so your scale factor is 4:3. Now, you have to know, is this an area problem or is this a perimeter problem? Well, if this is my floor, say this is my wooden floor, if I'm trying to refinish it, that means I'm covering the entire surface with this finish. And that means this is an area problem. So, if that's the scale factor, then to find the ratio of the areas, I must take the scale factor and square it. That would be 4 squared divided by 3 squared, which is 16 over 9. Okay? So that's the ratio of my areas. And now I set up a proportion. The ratio of my areas is equal to the ratio of my actual cost, right? This is going to be cost. And it costs $2.16 to refinish the smaller wood floor. So this $2.16 goes across from the smaller number. That means the cost of the larger is right there, X. And what I'll do is I'll cross multiply 9x equals, and 16 times 216 is 3,456. And I'll divide that by 9. And divide that by 9, I get 384, and that would be dollars. So that's how much it would cost to refinish the larger floor. So again, you cannot just use the scale factor, you must use the scale factor squared. Next, here we go. The figures in each pair are similar. The area of one is given, find the area of the other. Okay? So here we go. A very similar problem to the one above here. So we have scale factor given on our picture. So the scale factor is 16 to 12, right? It's a pair of corresponding sides. But these are divisible by 4. So that would be 4:3. That's your scale factor. So now again, this is the area problem. Area, the perimeter, the ratio of the areas is equal to the scale factor squared. That is 4 squared to 3 squared. That is 16 to 9. And that is the ratio of your areas. And now we set up our proportion, right? 16 to 9 equals, and we put our actual areas here, actual. Well, they give you the area of the large one, 105. That goes across from the bigger number, so then your smaller area, x, goes down here. 16x equals, and 105 times 9 equals 945. Divide by 16. And roughly, I get 59. And that would be feet squared. So there's the area of the smaller one. So again, I cannot emphasize enough that if you're dealing with areas, it is the scale factor squared. Please, please do not forget that. Okay. Alright, last problem here. Find the perimeter of the regular polygon. So if I look here, what kind of figure is this? 1, 2, 3, 4, 5, 6, 7. This is an octagon. 8 sides. N equals 8. So my area formula is 1/2 AP. Okay. So what I like to do is, again, I'll draw the figure down here. I don't like their picture up here. So we're here, we're here, we're here. There's my center. Here's my 2 radii. Here's my apothem. Here's my side length. Now, they are giving me the radius of 10. Okay? So this is different than the hexagon problem we did earlier. So if that's the radius, do I know the apothem? No. So 1/2 A. The number of sides is 8. And the side length I do not have. So leave it blank. So I have to find 2 things here. So now we go to our triangle. First, find the central angle. 360 divided by 8, that's 45 degrees. And now I'll take the triangle on the left because that's where they gave me the 10. Here's 10 meters. Now this bottom side, remember, is half the side length. So I say half S, which equals X in my opinion. A, right angle, and then this angle right here, if that central angle is 45, half of 45 is 22.5. Okay? And now, to solve for A and to find my side length, which involves this X down here, I'm going to use trig. And to use trig, I label the 3 sides hypotenuse, opposite, adjacent. And let's find the A first. To find the A first, we need the adjacent, and we know the hypotenuse, that's cosine. Remember this SOHCAHTOA, right? If you need to use this. So we're going to use cosine of 22.5 degrees equals the adjacent side, A, over your hypotenuse, 10. And we multiply both sides by 10. And our A value is going to be 10 cosine of 22.5. And I got 9.239. So that goes right here, 9.239. And now to find my x, I'm going to use the opposite and the hypotenuse, that's sine. Sine of 22.5 degrees equals the opposite x over your hypotenuse, 10. And you give me times by 10, times by 10, 10 sine 22.5 equals, and I got an x value of 3.827. But that is what half of S is. So times by 2 times by 2 to get what S is. And if I take 3.827 and times by 2, I get 7.654. And that is my side length, 7.654. So, when I plug this into my calculator, 0.5 times 9.239 times 8 times 7.654, I get 282.9. And that would be meters squared. So there you go. So again, these problems are a little bit longer, but there's a process. Just make sure you practice the process and life should be good. Okay? Study up. First major grade of the quarter. Let's make it a good one. We'll see you on Monday or Tuesday.